This is how the circuit is looking now. It has two op-amp integrators. I know I was trying to get rid of that jungle of wires, but I'm still getting a jungle of wires. And I believe I'm getting the correct signal out of this output. The only problem is that the signal is very, very small. So let me show you what is going on in the oscilloscope. Right now I'm simulating a second order differential equation, and the constant coefficients are dependent on the resistor values of the various feedback loops. And as you can see, I believe I'm getting the correct signal, because what you're seeing right here is the final output, which is x of t. And you can see that it's going up and down and it's diminishing, and then it repeats the process again. And I know that's one of the solutions to this differential equation. You can see how that is like a damping system for like a spring or some sort. So I believe the circuit is working for now. It's a very small voltage. I'm getting only 60 millivolts or so, and there appears to be a lot of noise. So what I'm thinking is that I could introduce a low pass filter depending on the frequency that is based on this output, and also amplify the signal. But all in all, I think this is working, although it doesn't look like it is. So since my friends are busy being imaginary and I have nothing else to do, I'm going to continue working on this. So right here, we not only have my life in the past couple of days, but also a circuit that solves a second order differential equation that can be non-homogeneous. And this is our output, which is x of t, or the equation that solves the second order differential equation. So apparently the signal is very small when going through all this circuitry, and I try to amplify the signal, but I'm getting an issue here. I know this is the correct configuration for an inverting amplifier, but it's not amplifying correctly. Maybe I have to recheck my circuit, but I don't think it's wrong. If you're wondering what this extra resistor and capacitor are doing, basically I'm amplifying the signal and then filtering out the high frequency noise that is apparent with the signal. So this is the solution to the differential equation, and this actually looks correct. I know the solution should be looking something like this. I mean, there are other forms of the solution, but I believe that the resistor values that I have for the circuit will cause an oscillation that decays exponentially. So this could be a system that models like a spring that has some sort of damping. So I think the circuit actually works. I have some sort of differential equation solver. Now the next thing I should do is actually buy some potentiometers so I could vary the constant coefficients in front of the various terms in the differential equation and see how the output changes, and it should change. So I'm happy to say that this project is almost done.